In version 5.3, MongoDB has introduced a new feature called a clustered collection, and I want to going into a deep dive into how this functionality works and how it can actually improve the performance of your reads and of your writes. And before we do that, we really need to explain how Mongo used to store collections and documents in these collections and the on-desk storage representation, if you will, and then how cluster collection can actually improve that. And of course, everything that we do in software engineering that has a cost. So when we introduce a new feature, it comes with its own limitations, and it's good to understand these limitations, right? So let's talk about clustered collections in MongoDB. So before we talk about clustered collections in MongoDB, I want to talk about how regular collections or unclustered collections, those regular collections that you create in version 5.2 or earlier, even 5.3, you have an option to enable those, right? The cluster collection. But how does the normal collections work? You see, and in recent versions, so version 4 and newer, Mongo acquired this data storage company called wiredTiger. It's a database engine that allows you to do this Mongo, that allows you to do ACID, multi-version concurrency control, and concurrency and other things. And the way wiredTiger and MongoDB stores thing is they have a hidden index. Now, the history behind this hidden index I discussed in my deep dive on the MongoDB architecture. If you want to go there, check that video out. But essentially, that hidden index, the key to that hidden index is called the record ID. And there's no way, as far as I know, to see that ID or that key. That record ID is a 64-bit integer, so 8 bytes. And in that hidden index, the key is that record ID, and the value in the leaf pages of that hidden index is the document that you store, which is the BASIN document, the binary JSON. And it's compressed and all that jazz for efficiency reasons. So when you submit a document to store in a collection, it goes into that hidden index that you don't see. Right? But then you might say, Hussein, I don't really deal with that record ID. I have an ID field, an underscore ID field, or I can create my own other indexes, right? So that other ID field that you actually visible to you, that is auto-generated for you, is actually another b+tree index. So there's one b+tree index that's hidden, right? And that's technically already clustered around that record ID with the documents. And the documents live in the leaf pages. Then you have the underscore ID, which is the object ID of that document. And that underscore ID field is actually around 12 bytes, right? In size, that key. And the value that in that b+tree, so when I say value, that when you do a traversal on that tree and you find that ID, the corresponding value, because b+tree is always a key value at the end, right? The leaf pages stores the value of that key that you just found. And the value is actually the record ID we talked about. Right? So we have, when you technically search for a document by its ID, you do the get on Mongo, the command get on ID. You actually do 2 reads. And MongoDB documents actually call it reads. It's actually kind of an understatement because it's not just reads. It's 2 b+tree seeks. It's not the same as just a read. A read indicate that it's a single IO. Not really, right? A read here, or a b+tree seek, you're actually traversing the internal nodes to find on the ID field, on the ID index, just to find the record ID. Then that doesn't give you the document. You have to take that record ID and then go to the hidden index and do another b+tree traversal, right? And if you know how b+tree works, you check the root, and then you intermediates, and then you go to the leaf, and then you fetch the leaf page, and then from the leaf page you find, oh, here's my record ID and here's my documents. And if you're lucky and that page holds many other documents, you cache this whole thing in the buffer pool. Hopefully the next record ID you request is in the same document, right? But unfortunately it never is, right? Because this thing is always random. It causes random IOs. The architecture of unclustered collection, which is the default, requires you to do a double read or double b+tree seeks, right? Just to find the document you're looking for. Same thing for a write. When you write a document, you write it in the hidden index and you update the b+tree structure for that hidden index. You get a brand new record ID. You take that record ID and insert it into the appropriate location after generating a new ID field for you, and then update that index. So you're doing double writes effectively. So to summarize, unclustered collection, we have the ID field as an index, and that points to, when you do a search, you find the ID, but then you don't find the document immediately that you're looking for. You actually find a record ID, a pointer. And when I say a pointer, I don't mean a C pointer here or a memory pointer. No, I mean an actual value that you use to do another traversal on another index, which is the record ID, and that will give you the index, the document. So there is 2 b+tree traversals. Now that we know that, the cluster collection, which is in 5.3 and 6.0, actually removes that hidden index altogether and then makes the ID index your clustered index. That becomes your clustered index. It means the document is stored in line in that ID index. Right? And of course, naturally, you only can have one clustered index because that's what you have, only one way to store your data. Right? So now when you do an ID lookup, you go use the ID index, and then you immediately find the ID key, and the value now is not the record ID anymore. It's actually the whole document, the basin document, right? And then you return it after you decompress it and do all that jazz. So that's what cluster collections is. So you're doing a single read, right? You're doing a single write. You're changing one thing instead of two. So your queries are faster, your updates are faster, your inserts are technically faster. Even your range queries are faster. Why? If you're doing a range query on the ID, give me all documents between this ID and this ID. And because the ID field is incremental, has a timestamp, right? I think in the first few bytes, then it's actually very nice to do a range query in a clustered index, because we know that these IDs will live together, will be next to each other. That will give us fewer page IO to disk, and we're gonna give, and all the documents that we're gonna look are on the same hot pages that we find, right? Compare this to the older design, where if you do a range query on an unclustered index, all you're gonna find is record IDs, right? But these record IDs, can you guarantee that they are actually exactly next to each other in the hidden index? Maybe, maybe not. So that will cause actually random reads on the hidden index. While sure that range query was sequential, the randomness to actually get the document to go to the hidden index, that is random. And random is bad when it comes to databases, right? We try to avoid random because when you do random, you're paging, you're reading from multiple places in disk. You're lowering the cases of logical reads, which is basically page hits on memory. And as a result, things can get slower. And as you pull in fresh pages that are random, you have to discard older pages that you didn't use for a long time. And most of the time, if you discard an old page, chances that you're going to need it again are very high, because everything is random and you have a limited amount of memory. So with that said, we know what a cluster collection. We know cluster collection. Let's go to the doc and read this and discuss more. All right, so this is the MongoDB official documentation. Clustered collections, new in version 5.3. Starting in MongoDB 5.3, you can create a collection with a clustered index. Collections created with a clustered index are called clustered collections. And you can only have one clustered index. We talked about what a clustered index is. It's when your data is in the index, right? And it's also called a primary index in other databases. So every time you hear the term primary index, it is mostly a cluster index, Postgres being the exception. And I think Oracle also is an exception, unless you create an index organized table specifically, right, by default. And even SQL Server have this idea. You can create a primary key, but you can make it a clustered index. So actually cluster your data around that index, right? As opposed to have it just as a heap table somewhere and point to it. Benefits, because cluster index store the documents ordered by the cluster index value, cluster collection have the following benefits over a non-cluster collection. Faster queries on cluster collection without needing a secondary index, such as queries, range equality, and equality comparison with on the cluster index. So if you're doing something on the cluster index, it's fast, because if you're looking for a certain document, it's in line in that document, in that index. There's no other jumping to another hidden index to get that document. It's right there. And we talked about range, how range scans are really nice. If you go, hey, give me all the documents, or just not all documents, just all the particular fields in a document in this range, right? Again, not cluster. Cluster collection have a fewer lower storage size, which improve the performance of the queries and bulk inserts. So the reason is have lower storage size because we used to store the hidden index with inline the collection and the data, the documents, and then we also had the ID index in a separate structure. So we're storing, we have two places to store things. We have this additional data structure that we manage. So more size, right? Plus the ID index is not is massive, right? It's 12-byte key, right? So it multiplies, right? Plus the record ID was 8 bytes, so you're storing 8 bytes and storing a 12-byte keys. So for each document, and add to that the overhead of the key management in the b+tree, the root, the intermediate nodes, it all adds up, right? So then the storage lower, or you might say, Hussein, I don't care about storage, but storage kind of almost translates always to I/O, right? Because if you're storing stuff in multiple places, then you need to read multiple places to do an I/O in multiple places to fetch the thing that you want, right? And that's the problem, really. Cluster collection can eliminate the need of a secondary time to live index. So they have a feature here called the time to live, where you can set essentially an expire after X seconds on the cluster index, and you can just use that feature to delete a document that expires. I think Redis has that feature as well, right? Cluster collection have additional performance improvement for inserts, updates, and deletes, and query. And here they go into details. All collections have an ID index. An unclustered collection stores the ID index separately from the document, as we explained, right? This requires 2 writes for inserts, updates, and deletes, and 2 reads for queries. They try to avoid talking about this hidden index because this is like a public user-facing document. But if you go to the forums and the threads, you can clearly see that details, right? You can see it in conversations, which I love, and also I think in the source code, which is Mongo is open source, right? A cluster collection stores the index and document together in ID value order. This requires 1 write for insert, update, and delete, and 1 read for queries, right? Again, when we say 2 reads and 1 read, we're talking about an actual b+tree traverser read. It's not a single I/O. No. It's not a single go to disk and hey, this is a read. No, it can cause multiple I/Os. 1 read is equal 1 or more I/Os here. All right, so be careful with this terminology. Okay? Here. Behavior. Cluster collections store documents ordered by the cluster index key value, right? And the key value for the ID, I think you can change it, which is something you have to watch out for, and we're going to talk about why. You can have one clustered index in a collection because the document can be stored in only one order, right? Makes sense. Only collections with a clustered index store the data in sorted order. You can have a clustered index and add secondary indexes to a clustered collection. Clustered indexes differ from secondary indexes. Now, here's the interesting thing. I think they do mention it here. Hopefully they do. A clustered index can only be created when you create the collection. So there are some limitations, I suppose. So they don't let you create an index, clustered index after the fact. That's, to me, that's just a limitation, software limitation. There's no technical reason not to do it. They want to do it later because probably, here's my guess. I think the reason they don't want to do it is because to create an index, they have to acquire an exclusive lock, like almost an access exclusive lock on the whole collection. You cannot do anything to that collection when I add a cluster index, and they didn't want to do that because it blocks reads and writes, right? So that's why they don't want to do it. This is just do it, just copy the collection to another collection and create the index, cluster index there, right? Because why do we need an exclusive access? Because we're reordering how data is stored, right? The whole thing is changing. It's a massive, big change. So cluster index have to be done from scratch or just created from the beginning. Cluster collection limitation. You cannot transform a non-cluster collection to a cluster collection or the reverse. Instead, you can. So they're talking about this, like how do you convert a non-cluster collection to a cluster collection? You cannot just do it. You cannot just, hey, add a cluster index, because that will acquire an exclusive lock and they will block reads. That's my guess, I think, right? They just don't want to do that. Or maybe there are more technical details that I'm not aware of, at least when it comes to Mongo, right? But I envision them having that feature in the future, definitely, because that's just right. That's just something almost all databases have, right? Let me just create a cluster index right now. By default, if a secondary index exists on a cluster collection and the secondary index is usable by your query, the secondary is selected instead of the cluster index. So we gotta be careful with this. I still don't understand why would the secondary index be preferred over the primary index. It's just weird, because what if I do like where ID equal blah and this field that I happen to index is X, right? It'll be really slow to use the secondary index just to get all these documents, right? And then filter the documents for that ID. So that is something really to watch out, because it can really cause degradation in performance, right? Because hey, I'm literally pulling one document and I happen to have another filter. You just happen to use that index just because I had it. A proper planner would say, oh, that's a more selective index, I'm going to use that. I don't have details as why they are doing that. It seems to be a bad idea, but there must be a technical reasons behind it. But so they tell you at least, hey, if you really know what you're doing, use a hint, which is good. I like that Mongo uses hints, right? Mongo supports hints. So in that case, like if you're actually doing something like this, right, then probably just hint the planner, say, hey, please use this cluster index. So something to watch out for here. The clustered index key must be on the ID field. Sure, okay. You cannot hide a clustered index, hidden indexes. That's another thing. If there are secondary indexes for the cluster collection, the collection has a larger storage size. I'm glad I mentioned this. Let's talk about why the secondary indexes have a larger storage requirement in cluster collection. And here's why. So to explain that, we need to know how secondary indexes work in unclustered or non-clustered collections. They do by the secondary index actually points to the record ID back in the older model, right? So both the ID and all the secondary indexes point directly to that record ID, which is just another b+tree data structure. So if you search by ID or search by the secondary indexes, you are incurring the double reads we talked about, the double b+tree traversal. Okay, and the secondary index in this case includes the key that you're indexing. Let's say this is the date of birth or the salary or whatever the field is in the document. And then the value of the secondary index is the record ID, which is what we said is 64-bit, 8 bytes, right? So that's fixed, 8 bytes, never changes in the older. In the new model, in the clustered collection, the secondary indexes point not to the record ID because that doesn't exist anymore. What does it point to then? You don't have a choice. You have to point to the ID key. So that makes it identical to the MongoDB MySQL model, right? Where now we're pointing to the primary key values. What is the size of the primary key? It is 12 bytes, not 8. So that's an additional 4 bytes you're incurring on the secondary indexes. So yeah, so you're incurring an additional 4 bytes in this case, right? Which might not seem much per record, right? But can add up, right? So a few extra megabytes, 4 or 5 megabytes, right? And it can add up, right? And especially if you have a lot of indexes, it can really add up. And what can make it worse is if you did choose to change the ID field content and you're not using the default. That's the default is 12 bytes. If you, let's say, I've seen a lot of people use UUIDs, for example. And UUIDs, if you do store them, I suppose those are stored as string, right? If you store UUIDs natively, they are 16 bytes, 128 bits. But we rarely store them this way. We store them as a string and with the dashes, and based on whether it's UTF-8 or other encoding, that gives you like 36 bytes. That's a lot. That is a lot of bytes, right? So you're jumping from 8 bytes to 36. So that is massive per record. So there's like a significant difference. So you're talking about what, 28 bytes extra per record. So that makes your secondary indexes larger. You might say, who cares if the secondary indexes are larger? Well, the moment things get larger, IOs suffer. And the reason is because the page size, what is the page size in MongoDB? It says here wiredTiger is 4 kilobyte. I don't know if that's correct or not, but if it's really that small, then yeah, you need to do more IOs to fetch what you need, right? More pages. You need to pull more pages to fetch the things that you want, right? Because it's just the thing that you want is no longer fits in one page. It's in multiple pages, right? So the larger the index, the slower it gets to pull, and you're trying to find what you're looking for. And and of course they go into the details here and how to create it. So they go into details here. So it should be small size as possible, talking about the key, because very critical, the key value, selecting that key for the cluster index is critical, right? Because it does support up to 8 megabytes in size. That just sounds like a bad idea to have a key in 8 megabytes. Like that is gonna be showing up in all your secondary indexes. If you don't have any secondary indexes, who cares? That's fine. But that's that sounds like a bad problem to have. So, but a smaller key is better. A cluster index key is better, of course. A large cluster index key causes the cluster index to increase in size and the secondary indexes to even get larger. This reduces the performance and storage benefits of the cluster collection, as we explained, right? Secondary indexes on a cluster index with large clustered index keys may use more space compared to secondary index with non-cluster, because the secondary index with non-clustered are fixed to, because they're pointing, their values point to this 8-byte record IDs, while the secondary indexes and cluster indexes in cluster collections, they point to this massive thing, the whatever you have in that case, right? So be careful of that. Here's a short example how to create a collection. So you would specify a clustered index, and it has to be this key ID 1, right? And it has to be unique, of course, and you can give it any name you want. And here they give you how to do these examples. But yeah. So that's what I thought I'll talk about, cluster collections. Sounds like an interesting feature. If you're using MongoDB or you're planning to use this feature, let me know in the comment section below. Gonna see you in the next one. Goodbye.